Hello students, in last lecture we discussed the different types of chemical reactions of the fats and oil. The first reaction, that is the hydrolysis reaction. In hydrolysis reaction, when the fats and oil are react with the alkali, it can produce the sodium salt of fatty acid. It is called as a soap. It is called as soap. So this reaction is also called as the saponification reaction. If we use KOH instead of NOH, if we use the alkali KOH instead of NOH, then sodium salt of fatty acid is obtained, and this is nothing but a soft soap. As this method is useful for making soap, so it is also called as saponification reaction. Hydrolysis is also done by using water. When water is mixed with oil or soap, it can produces glycerol and fatty acid. Hydrolysis is also done by using the enzyme like lipase enzyme or mineral acid like sulfonic acid. Next reaction we discussed, that hydrogenation reaction. Hydrogenation is done by using the catalyst like platinum, palladium or nickel. At that time, the double bond O present in unsaturated fatty acids of the oil get breakdown and converted into single bond. See here the reaction. The liquid oil like triolene oil, when undergoes hydrogenation reaction in presence of catalyst like nickel and under pressure condition, this triolene containing unsaturated fatty acid is converted into triostyrene containing saturated fatty acid. See here, after addition of the hydrogen, C17H33 in oil becomes C17H35. Hence the melting point of the oil is increases after it becomes the fat. Mostly this reaction is useful for manufacturing of vanaspati ghee or dalda from vegetable oil, or vegetable ghee is manufactured from vegetable oil. There are two types of hydrogenation, partial hydrogenation and complete hydrogenation. After partial hydrogenation, some amount of the double bonds are hydrogenated and while others are left in place. That means partial hydrogenation takes place at that time semi-solid material is obtained, that is nothing but a fat. It is soft and semi-solid in nature. If we do the complete hydrogenation, the product obtained is very hard. Next reaction, that is hydrogenolysis. What is meant by hydrogenolysis? Hydrogenolysis means by using the hydrogen we can break down the compounds by using the catalyst, that is the copper chromium catalyst under pressure condition. We break down any compounds, maybe fat or oil, we can break down by hydrogenolysis. The word meaning hydrogenolysis, by using the hydrogen lysis of the compound, that is the breakdown of the fat or oil. See here the example, styrene. Styrene, when undergoes hydrogenolysis after addition of the hydrogen, this under pressure condition in presence of the catalyst like copper chromium oxide, at that time this styrene fat is converted into glycerol and higher alcohol, that is octadecyl alcohol. That means this hydrogenolysis process, after hydrogenolysis of fats and oil, these are converted into glycerol and higher alcohol. Hydrogenolysis means splitting of a given compound by means of the hydrogen. Sometimes the hydrogen Sometimes this hydrogen useful for hydrogenolysis process can be obtained by reaction between the metallic sodium and hexanol. This hexanol is water insoluble compound. Next reaction we have seen that the rancidification. Rancidification means what? After long storage of fats and oil, they undergoes the decomposition reaction and start to smelling unpleasant smell and its taste becomes sour. This process is also called as rancidification, and oil is said to be the rancid oil. Rancidification is caused by different causes. First, that is the oxidation of unsaturated acid. As these unsaturated acids are present in the oil, when they are come in contact with oxygen, undergoes oxidation, and these unsaturated fatty acids present in the oil are converted into peroxide, and these peroxides are again break down into the aldehyde, and these aldehydes having unpleasant smell and sour in taste. Another reason or another cause of rancidification, that is enzymatic hydrolysis. By enzymatic hydrolysis, the fats are converted into fatty acid. If we store the fats for a long time, at that time the microorganism can be attack on that fats, and these fats get hydrolyzed by the enzymes which are produced by the microorganisms, and these fats are converted into the fatty acid, where the hydrolysis is takes place by enzymes which are produced by the microorganism, and fats are converted into fatty acid, and this fatty acid having sour in taste and unpleasant smell. For example, if we store the butter for a long time, it becomes rancid and it can be converted into the butyric acid, and the taste of the butter become sour. Instead of buttery taste, its taste become sour taste. The next cause of rancidification, that is beta oxidation of saturated fatty acid. These saturated fatty acids are present in oil. Similarly, unsaturated fatty acids are converted into aldehyde. Similarly, these saturated fatty acids present in the fats are converted into ketone. See here, this ketone containing one carbon less as compared to this acid. See first, these acids present in the fats undergoes beta oxidation. See here, after COH the first carbon come, that is alpha carbon, near to this, next to this alpha, that is beta carbon. When this acid come in contact with air, at that time the beta carbon get oxidized. See here, the alpha CH2 and this is beta. Beta CH2 becomes CO. CH2 becomes CO here, and there is a formation of beta caprolic acid. After oxidation, the fatty acids are converted into beta keto acids. See here, the caprolic acid after oxidation, beta oxidation converted into beta keto caprolic acid, and then this beta caprolic acid after decarboxylation reaction is converted into ketone. See, this keto caprolic acid is converted into methyl and amyl ketone. See here, the one carbon is less. The one carbon from the caprolic acid is become less here. Next reaction today we seen, that is the drying of the oil. Then what is meant by drying of the oil? When oils containing unsaturated fatty acid or maybe saturated fatty acid, they exposed to air. The oil contain unsaturated and fats contain saturated fatty acid. When they exposed to air, they undergoes the oxidation and polymerization process to form the thin waterproof coating on the surface of the oil. For example, in oil paint is a mixture of color pigment and liquid medium is nothing but oil. When these oil paints are exposed to air, at that time there is a formation of a coating on the surface of the oil paint, that is nothing but drying of oil. When highly unsaturated fats are exposed to air, or unsaturated oils are exposed to air, they undergoes the oxidation and polymerization to form a waterproof thin coating on the surface. Such oils are called as drying oil. Oils depend on exposure to light and air. They are classified into three types. First, that is non-drying oil. When they expose to light or air, they get rancid and decompose into glycerol and fatty acid. This acid may be saturated or unsaturated depending on fats and oil. The unsaturated acid get oxidized to form the aldehyde, in which the one carbon is less as compared to initial fatty acid. We can see this in this reaction. See, the caprylic acid, saturated fatty acid, converted into ketone having one carbon less. Similarly, if saturated fatty acids are present, they are converted into ketone. For example, olive oil or almond oil. Then next, that is drying oil. They form the solid elastic film after oxidation. When they are exposed to air, they form solid film or coating on the surface of it. And good drying oil can be dried within 4 to 5 hours. So these drying oils are mostly useful for making the paints. For example, linseed oil is useful for manufacturing of the paints, as it is the basic medium or base of the paint. This linseed oil containing linolenic acid. Due to this acid, it is the drying oil. Next, that is semi-drying oil. This oil having high concentration of linoleic acid and low concentration of linolenic, as due to low concentration or low content of linolenic acid, they are semi-drying oil. If the concentration of the linolenic is high, at that time oil is drying oil, but it contains both acid, that is linoleic and linolenic acid, so they are semi-drying oil. For example, sunflower and cottonseed oil. Drying oils are used as a medium for paint. Paint are the suspension of, or it is a mixture of color pigments or the organic coloring matter in a linseed oil, because linseed oil is a drying oil containing linolenic acid, high concentration of high content of linolenic acid. And to this oil we may add the thinner like turpentine to avoid the oxidation or to make the paint thin. These paints, when applied on wooden surface or on a wall, they quickly dry up and forming a tough organic coating and protect that surface. Next, that is the analytical constant. Next point, analytical constant. What is meant by analytical constants or analysis of the fats and oil? The fats and oil are the important components of various medicines, lubricants, varnishes, lacquers, soaps, as well as other items. In daily life, we can consume the fat and oil in one or many forms. The value of particular fat and oil, or the quality of the fat and oil, is depend on its composition and its purity. A variety of the physical test has been performed to check whether it get rancidified. Is it rancidified, or it undergoes hydrolysis to check these qualities. A variety of the physical tests have been performed to check the composition and the quality of the fats and oil, and these tests are known as the analytical constant. In next lecture we can study these different analytical constants or these different tests. How this test can be performed experimentally, that is acid number, sap number, iodine value, ester value, Rm value. In next lecture we study these analytical constant, how we can determine these values, and from these values in which way we can say that these fats and oil are good quality or not.